Hi you guys, today's lesson is on naming properties. Okay, that's what we're going to be doing. So I want you to make sure you have your packet that I just gave to you out, and as you watch this video I want you to be following along with that and taking notes and participating when I ask you to participate. So the first property that we are going to talk about is the commutative property. Properties in math are basically just rules that we have to follow. The nice thing about math versus English is that in math, when we have rules, we follow the rules. Unlike English, where you have all these rules and then there's always exceptions to the rules. In math, there's not exceptions to the rules. Okay? So the first property we're going to talk about is the commutative property. So I want you to go ahead and just look at these examples. It says the sum of both 8 plus 7 plus 2 and 8 plus 2 plus 7 is 17. So as you look at these two expressions here, you can notice that in the first one, it was 8 plus 7 that you're adding first and then adding the 2. In the second one, you're adding the 8 plus 2 first and then adding the 7, but in both cases, the answer is still 17. Okay, let's go ahead and look at the next one. The sum of both 13 plus 14 plus negative 3 and 13 plus negative 3 plus 14 is 24. So it doesn't matter the order that you add in. If you're adding, you can add in any order and you still get the same answer. Okay. The commutative property when it comes to multiplication, let's look at a couple of examples there. The product of both 1/2 times 7 times 8 and 1/2 times 8 times 7 is 28. So notice that when you multiply, you can change the order that you're multiplying in and you still get the same answer. Okay, in both of these cases, the answer is 28. And for the next one, the product of both 9 times negative 1/3 times 7 and negative 1/3 times 9 times 7 is negative 21. So in both cases, it doesn't matter if you multiply the 9 times negative 1/3 first and then multiply by 7, or if you multiply the negative 1/3 times 9 and then multiply by the 7, the answer is negative 21 in both cases. Okay, so commutative property. Notice that all of the examples that you were given here were for addition and multiplication. Now let's look at the next part of your notes guide. Which pairs of expressions are equivalent? So I want you to quickly pause this video. I want you to go through and do 1, 2, 3, 4, 5, and 6, and I want you to say whether the pairs of expressions are equivalent or not. Now, expressions, that basically just means a math problem that doesn't have an equal sign, and equivalent means equal. Okay, so are their answers exactly equal? So push pause, go ahead and say yes or no for each of these pairs of expressions. And then push play and we'll go over the answers together. Okay, so here we go. Number 1, 12 plus 4 and 4 plus 12. We would say yes, they're equivalent. 12 plus 4 is 16, 4 plus 12 is 16. Number 2, 9.8 subtract 3.4. Okay, and if we change our subtraction to addition, we would change this to same, change, change. And then this one would be same, change, change. Okay, so 9.8 plus a negative 3.4 and 3.4 plus a negative 9.8, those are not equivalent. For the first one, we would have 9.8 minus 3.4. If we line those up, we get 6.4. And on the second one, it would be a negative 6.4, and those are not equivalent expressions. Okay, number 3, 12 subtract 4, we know that's 8. If we change this to adding a negative, okay, we know that's a positive 8. 4 subtract 12, We change this to adding a negative. That would be a -8. These would not be equivalent, okay? 8 is not equivalent to -8. Number 4, we would say yes, 5 times 4 is the same as 4 times 5. Number 5, 3 times 0.09 and 0.9 times 3 is a yes in both cases. That would be a 2.7. And on number 6, 18 divided by 6. If we put 18 in the box divided by 6, that is going to be a 3. But 6 divided by 18 is not a 3. It's actually a 0.33 repeating as a decimal, or if we write this as a fraction, 6 divided by 18, that fraction simplifies to 1/3. But either way, these expressions are not equivalent. So in the next part it says, what pattern are you noticing? So what you should notice is that when you are dealing with addition or multiplication, you can multiply or add in any order. If you are dealing with subtraction or division, if you change the order, it changes the answer. The answers would not still be equivalent. Okay, so in your own words, on your paper, I want you to write down what the commutative property is. And I would probably say something like, the commutative property says you can multiply or divide in any order, and it doesn't change the answer. But you cannot change the order of subtraction or division and come up with the same answer. Okay, let's go ahead and talk about the next property. The next property is the associative property. Okay, so let's look at these examples here. We have the sum of both 3 plus 7 plus 4 plus 16, and 3 plus 7 plus 4 plus 16 is 40. Now notice what's happened here. The parentheses are just placed in a different spot in the expression. Okay. Also notice that in this expression, both of these expressions, it's addition. Okay. So for the first one, it doesn't matter if you put the parentheses around the 17 plus 4 first, and then add the 3 plus 16, or if you put the parentheses around the 3 plus 17 and the 4 plus 16, add those both together. After you get that answer, you'll still get a 40. Okay, so it doesn't matter which one you associate with first. If you're talking about addition, you can group them any way that you want, and you still get the same answer. The next example is dealing with multiplication. So you can see we have 2 times 5 times 3, and we have 2 times 5 times 3, and both of those give you a 30 as the answer. Okay, so it doesn't matter where you put the parentheses when you are doing multiplication. So when the operations are the same, but you're grouping in different ways, as long as it is addition and multiplication, that works. So let's go ahead and do the same thing that we did on the commutative property. I've given you some expressions here, and I want you to tell me if these expressions are equivalent or not. Okay, remember, when you are simplifying an expression, you always have to follow the order of operations, which says parentheses first, then exponents, then multiplications, divisions, then additions and subtractions. So go ahead and pause the video, simplify each of these, and then say yes or no as to whether they are equivalent or not. Okay, number 9 is a yes. 12 plus 4 is 16, and then 16 plus 6 is 22, or 4 plus 6 is 10, 10 plus 12 is 22. Number 10 is a no. Okay, if we do the parentheses first, 12 minus 4 is 8. 8 minus 3 is a 5. 4 minus 3 is a 1. And 12 minus 1 is 11. Those are not equivalent. Number 11, we would say yes. 3 plus 5 is 8, plus 17.4 is 15.4. Or 5 plus 7.4 is 12.4, plus 3 is 15.4. So that one is a yes. Number 12 is a no. Number 13 is a yes. Number 14 is a no. If you take 8 divided by 6, that's a 3. 3 divided by 3 is a 1. And if you do the 6 divided by 3 first, that's a 2. And 18 divided by 2 is a 9. Those are not equivalent. Number 15 is a yes. And number 16 is also a no. 24 divided by 12 is 2. 2 divided by 3, that would be 2/3, or 0.66 repeating. For the next one, though, 12 divided by 3 is 4, and 24 divided by 4 is 6. So these expressions would not be equivalent. So now, what patterns do you notice about the problems that we're given? Well, we would say that when we are dealing with addition or multiplication, you can change where you're placing the parentheses, and it does not change the answer. When you're dealing with subtraction and division, though, you can't change where you're placing the parentheses, or else it changes the answer. Okay, so in your own words, go ahead and write down what the associative property is. The next property we're going to talk about is the identity property. The word identity has to do with sameness. We use this word when we recognize the sameness between things. For example, you might say that a Halloween costume cannot really hide a person's true identity. Okay. Above, we defined the associative and community properties for both addition and multiplication. So now we're going to do the same thing for the identity property. So what do you think the identity property for addition should mean? Well, the identity property for addition should mean that when we add something to a number, it does not change the number. The only number that we can add to another number that won't change its identity would be 0. Okay, if we add 4 plus 0, we still get 4. Or if we add 5 plus 0, we still get 5. Or if we add 1/2 plus 0, we still get 1/2. Okay, so in your own words, what is the identity property of addition? And we would say, well, any number added to 0 still equals that number. Okay, now let's talk about the identity property for multiplication. If we're talking about an identity property, that means when we multiply a number by another number, if it doesn't change the number, that would be what the identity property means. So the only number that you can multiply by another number that doesn't change it would be 1. 4 times 1 is still 4. Or 5 times 1 is still 5. Or 1/2 times 1 is still 1/2. So the identity property for multiplication says if you take a number, any number, and you multiply it by 1, you're still going to get that number. Okay. So just as a review, the identity property of addition basically says that if you add 0 to any number, the answer is just that number. The identity property for multiplication says if you multiply any number by 1, your answer is just that number. Okay, let's talk about inverse properties. The word inverse means opposite or reverse. You might say forward is the inverse of backward. There is an inverse for both addition and multiplication. Okay, so Inverse properties. Inverse properties are undoing properties. Okay, so we want to think about what we can add to a number to make that number be a 0. Okay, so 25, what do you think should be the additive inverse of 3? So additive inverse, what can we add to 3 to cancel out the 3 to make it a 0? Well, that would be if we add a negative 3, because 3 plus a negative 3 is what would give us 0. So the additive inverse of 3 would be negative 3. 26, what do you think would be the additive inverse of negative 3? Well, if we take negative 3 and we add to that a positive 3, that's what undoes the negative 3. Okay, that's what makes it a 0. So the additive inverse of negative 3 would be a positive 3. 27, we're talking about multiplicative inverse. When we talk about multiplicative inverse, we want to be able to multiply the number by another number and end up with a 1. Okay, so when it asks for the multiplicative inverse of 3, what can you multiply 3 by to get to 1? And that would be a 1/3. 3 times 1/3 is 1. So the multiplicative inverse of 3 is 1/3. Or, what do you think the multiplicative inverse of 1/3 would be? Well, the multiplicative inverse of 1/3 would be 3. 3 is what you can multiply 1/3 by to get to 1. Okay, so in your own words, what is the inverse property of addition? And in your own words, what is the inverse property of multiplication? Remember, the inverse property of addition is what you can add to the number to make the answer a 0. The inverse property of multiplication is what you can multiply the number by to make the answer a 1. So I want to just practice a couple of these really quickly. Let's say we have 2. If I ask you what the additive inverse of 2 is, you would say negative 2. If I ask you what the multiplicative inverse of 2 is, you would say 1/2, because 2 times 1/2 gives us a 1. Okay? Or if I say, what is the multiplicative inverse of 3, you would say 1/3, because when you multiply 3 by 1/3, you get 1. And if I say, what is the what is the additive inverse of 3, you would say a negative 3, because negative 3 is what you add to 3 to make a 0. And the last property we need to talk about is the multiplicative property of 0. This is the easiest one to remember. The multiplicative property of 0 basically says any number multiplied by 0 is 0. Okay, and this is something that you guys have known for a long time. Any number multiplied by 0 is a 0. Okay? Examples, 5 times 0 is 0. 256 times 0 is 0. Negative 46 times 0 is 0. And I just want to quickly review with you division of 0. Since we're talking about multiplying by 0, you need to realize that 0 divided by any number is always 0. And a number divided by 0 is always undefined. Okay, now at this point, you guys are ready to complete your homework or your individual practice for this lesson. Okay, so I want you to turn to the one that says homework, naming properties of arithmetic. Okay, so you're going to take these notes that you just took and you're going to use those to help you do these problems. There's actually 2 pages here, 1 through 23. Okay, so you're doing 1 through 23. You are then going to check it off with me before you move on to your next lesson.